It is a necessity. Look here. So first of all, Industry 4.0 was invented in Germany, and the colleagues coming from Germany, they know very well, in 2011. So for the first time, it was coming out in 2011. And this was a new paradigm because the German guy says, hey, we have to maintain our leadership in Europe and also around the world. What should we do more? And then they put together, Fraunhofer Institute, government, or whatever, then they built up this new word, Industry 4.0. Industry 4.0 at the time was a way of producing in a very flexible way with reduced cost. That means increasing complexity. Complexity means increasing also technology inside. And this stayed over there. In 2011, in Europe, the European Parliament, the government says, hey guys, here we have a topic. Because those numbers are coming from 2010, but it's not so far from the actual situation. You can see what is happening during the years. China, in 1980, it was at the 7th place worldwide in terms of manufacturing. China in 2010 was at the 2nd place. And the same was for India, that is growing up. And we were losing, in Europe, we were losing our capacity of generating, our capacity of exporting. So we were somehow overcome from China. It is, every one of you can note it. At that time, we have a total manufacturing industry was producing more than 7 billion euro. And if you look, at that time, it was just a 50% of GDP, giving a lot of works, direct and indirect, but still it was not sufficient. So Europeans say, hey guys, yeah, we have to go back at least to 20%, because if we would like to sustain workforces in Europe, we have to sustain the manufacturing. So the idea was, we have to do something in order to lower our production costs, to make our companies much more flexible, in order that we can inshore again workplaces that we have offshored in labor cost in countries like China, where the labor cost is still today one of the pillars. So if you look here, this is a statement coming from Antonio Tajani. Today is actual president of the European Parliament, but at the time it was vice president of the European Commission. And here, you see, they clearly said, we have to apply Industry 4.0 developed in Germany because we have to re-industrialize Europe. We have to have back working place in Europe. So this was a statement. Think about that, because during my speech afterwards we will see that it's not, at that time it was not completely clear what was the future, because now the future is changing. So please keep in mind that the idea was to locate again in Europe working place. But to do that, we had to reduce the labor cost. To do that, we had to make our production system much more flexible. It means that we have to stay connected with the market in order to be flexible, in order to produce only what is necessary, avoiding stock, and be really flexible at giving an answer in a very quick way. And on the other side, to be really customized. It means you need something, I will provide you exactly that. We will see how, because to do that, easy to say, not easy to do. There are a lot of technologies that are necessary to do that. So the idea that stays behind is, if I'm able to produce at lower cost, to be flexible and to be quick, then we can put again back Europe at the top of the manufacturing in the world. So this was the idea. To do that, we have to develop technologies that now we are going to see. Think about that, because in the meantime the world has been changed, or is changing, so there are other threats about. Just to give you some ideas, you can also refer to that numbers here. There are some good. Roland Berger was also estimating, and this is one of the best papers I found. Roland Berger was estimating the amount of the investment we have to do in Europe to gain this working place. And Here we are talking about every year in Europe. If we would like to reach in 2020 this 20% again of the GPD, even if today this target, it's impossible. We have to invest almost 80 billion euro per year in Europe. You can imagine, it's a huge. And these 80, they have to come from private and also from public. It's a huge number. So it was just an analysis, a mathematical analysis. But just to give you an idea, what we are dealing about when we talk about 20% of GDP in 2020. Almost not reachable so far. But it remains a standard. So if someone of you would like also to deep dive here, this is one of the best documents I've found. But as I said at the beginning, let's understand what is Industry 4.0, because there are a lot of misunderstanding about it. And really I would like to show also with a couple of videos, what is Industry 4.0 and what is necessary to do tomorrow. So I do not spend a lot of time, which is the first one and second one, so every one of you knows what was the first and the second. But let's say about the third one. Third one is, we are talking about here 1917, more or less, and it was the introduction of PLCs. It means it was the introduction of electronic parts within the assembly, within the production. So the machine, until then, more or less, they were moved from mechanical systems. Mechanical system means that every time you have to change it, you have to change the whole system. But starting from let me say year 2000, we had inside the so-called PLC, so we can change the movement of the machine just by making some software adaptation. If you look back, there are a lot of people who think that Industry 4.0 is just to have robots in the factory. It's a big mistake, because robots are already there since 20 years. This is not Industry 4.0, this is 3.0. And the robot, they stay in their production, in their position. They stay there and they make some repetitive movements. Of course, they already reduce the heavy job for our workers, of course. But this is Industry 3.0. Industry 4.0 is coming from the fact, and now we go back again to Internet of Things, that the things can talk each other. Talk each other means also they can take decisions. Now you talk about machine learning, and our machines, the more we go on, the more are in condition of getting information, having algorithm inside, and taking some decision. Of course there is a limit, we will see which is the limit. But the machine today, the things today, they talk each other and they can take decision. Today we have also the possibility of having a lot of simulation. I'm pretty sure there are a lot of people in the group who talk and deal with simulation. Today there is a cyber physics where we do not have to make prototype or whatever. We can simulate it. We have the virtual world where we can play a little and then we can introduce in the physical world. So machine can talk each other and take decision. Virtual world, so we can reduce a lot of our efforts. And this is the Internet, this is the Industry 4.0, where human and robot can work together and where the machines can decide and where we can have really flexible production system. And here, look, of course this is a vision, but you can see easily which is 3 and what is 4. The question is now, do we need to be everyone 4.0 ready tomorrow? The answer is no. The answer is no. It's clear that company like my company, like Bosch, like Siemens, like BMW, it's clear that we are making the new frontier. But if you look back at the other companies, and you will see, for instance, in Italy, it's not necessary that they are ready tomorrow. Important is that we know what is it. This is very important. Here the university can play really a huge role. Important is that we indicate the direction, but 3.1, 3.2, 3.25 is still valid. This is my first message. Is still valid. So we have to indicate, and we have to make conscious entrepreneurs students that we have to choose which is the best technology for us. So we do not have to be as it's there. Of course, we are doing something. Maybe there are already companies along in the world who are already 4.5, I don't know, or 5, I don't know. But we do not have to. So this is very important. Now, also here, if someone of you would like to have some scientific background, Germany developed the roadmap, Industrie 4.0 roadmap that you see here. And for those of you who would like to have a look at it, it's really well defined. So what are the technologies, what should be the application or whatever. It's really, really a roadmap. Here in Italy, in Italy we did something more or less like that, so we copied a little. And I have to say it was much more developed at the university. And if you look at that document, it's a little list of technology, but it doesn't say anything about how to do that. Because the topic is the technology, okay, we have the technology, but how to apply? Who is the consultant for the entrepreneurs to apply it? So here there is a gap. In the German one, there is already something more because there are also some institutes who are helping the entrepreneurs to apply the technology. In Italy, not. And I think also in Spain, not. Also in French, not. I don't know, honestly speaking. What stays in the middle, definition of technology, university, and entrepreneurs, is there is a bridge, there is no bridge over there. And this is something that we have to cover, otherwise there will be no development at all. So I will leave here if someone would like to have a look here of the sources. Technologies. About Industry 4.0, most of says that this is the fourth revolution. For me, it's not a revolution. It is an evolution. What is really revolution is that the technology that we are talking about, that just for, this is a list, but I don't know if this is the last of the last. Maybe there are a lot of other technologies, but if you look in the documents, mainly the technology we are referring are mechatronics, robotics, collaborative robotics. Collaborative robotics or cobot means robot who can work with us, with the humans. They have sensors, they can stop, they can upgrade themselves, they can decide what to do. Then we have Internet of Things, big data, we will see big data, it's really, really, really important. Cloud computing, informatic security, 3D printing, that is additive manufacturing, or simulation, nanotechnology, smart materials. So what is really the revolution, the real revolution is that those technologies that are having the highest speed in development in the history, that are available at really, really sustainable cost. So here is the revolution, is that the first time in the history we can really adapt the technology to what is necessary to us. Today, if you talk about a cobot, an ABB cobot, I'm taking one from my application, my plant, I'm spending 40,000 euros. A cobot, nothing. Okay, nothing, there are 40,000 euros, but think about what could be 10 years ago. If you look about a 3D printer, you can also buy a 3D printer for 1,000 euros. And if you would like to make a show or to have a prototype for us, for instance, I do not have to build up mechanical prototypes. When I have to show to the customer, then I make it with the plastic in one night, I can show that, 1,000 euros. Think about it. Or a cloud, a server, it doesn't cost anything. So what is the revolution is that the technology is available. Our job, your job, is also somehow to show how to use the technology. How to use the technology. This is also a big, in Italy we are really insisting on that. The university has also to show, first of all, to develop specialists in that, because we need new knowledge, and you will see afterwards. And second, we have to give also the direction to the students and also to the business, to the companies. On the left side, on the right side, you see government. In Italy, we are having a huge program to help company in adopting it. And this is one of the best in Europe, I have to say. Maybe it's one of the best in Europe today. We are investing a lot in Industry 4.0, a lot. And today the company would like really to make a step ahead in Industry 4.0. It can get also 40% of contribution from the government, 40%. Of course, you have to demonstrate that you are having connected technology. Here are the benefits. One of the benefits is, I'm sorry, this is in Italian, but well understandable. One of the benefits, productivity. Productivity, productivity. It means that we have to be flexible and produce with the best technology at the lowest cost. No way around. If we produce with the lowest cost in Europe, then we can maintain and sustain our company over there. Otherwise, it will be not paying off. Let's have a look. Can we have a receipt, an international receipt or unique receipt for everyone? No. The answer is already no, because if you look here, when we talk about Italy, 82% of the companies are with less than 250 employees, small companies, small, medium companies. And if you look, for instance, in Spain, it's more or less the same. So small company, first of all. So we have to deal with small companies, but not only. When we look here, the big part is property, under the familiar property. So that is a lady, a man who is property of the company. And the bad thing, from my point of view, is that they are also family managed. Family managed. So I mean, I'm the owner and I'm also managing it. If you look at the other, for instance, in Spain, in Germany, whatever, there is a managerial business. And think about, I'm not saying that the family managed company are bad, but for sure, the approach of a manager in the most of the cases is different than the familiar approach. A manager sometimes is also a little cooler in taking decisions and developing the company. If I'm the owner, and if I'm the man or the lady who made the miracle to make from 0 to 100 million euro turnover, then I say I'm the king, I decide what I have to do. But I'm not cool enough or cold enough to understand what is necessity from our company. And to close, in Italy, we have an age of the entrepreneur that is much more than 64 years old. I'm not against the old guy. I'm not against the old guy. But of course there is a difference between me and a guy of 30 years. It's a matter of fact, in terms of speed, in terms of whatever. So I'm not against, but it's a fact that in our company in Italy we have a lot of old guys guiding the companies. But if I look at Google, if I look at the most successful companies, I have to admit there are a lot of young guys there. So, what does it mean? That for us, we have, and I think this is quite, it's more or less the same also here in Spain, it's somehow the same also in French, I don't know, but we have more than 80% small, medium-sized company. High number of familiar property, and the age of entrepreneurs is 64. Colleagues, here we need a customized application. So when you talk about Industry 4.0, we cannot apply the same methodology we have in Germany, of course. We have to apply. So what could be, if this is, what could be the application? Well, we have developed that pyramid here. If you think about your daily life, everything, also in the kitchen, whatever you do, I make a measurement, then I have the transmission of the data, what I have measured, then I have to analyze the data, and then I have to take decision. So this is the fundamental pyramid we have developed, me with some colleagues. Think about whatever you think, everything is passing through that pyramid here. So, if this is the basis of each and any process, the difference is that today you have all the technology to use properly the data. And now we go to one possible application, data. We generate a lot of data. If you go in the company, if you go into university, you have a lot of data in archive or whatever. But who is using that data to take a decision? Who is using that? The revolution stays in the fact that today I can have the data. We have a huge amount of sensors. Today we are developing low-cost sensors that can measure whatever you want, pressure, humidity, speed, whatever. And also in your handy, you have a lot of sensors inside. You can go running, you can get whatever you want. So sensors, availability to measure everything. you have the possibility, so data, in the past, data today, but we can measure it without having people in making measurement. In the past, the data, we have difficulty to let them flow in. Today, we have infrastructure where you have terabyte flowing quickly. So we have high-wave data, actually. And what is really the good news is that we have also algorithms. We have web-based algorithms today, and we can make the analysis of the data. So the data that some years ago they were in archive, today they can talk about. They can give trends. They can give you idea. And if you have a trend, the machine can also decide what you want. So here is the really revolution. And here I will show you a possible approach of that. So think about that today, really we can use the data. And we can also link together the data. We can have data coming from a computer, from a sensor, and also from a camera. Think about it. A GoPro costs 200 euros. I can put a GoPro on a machine and I can link the data coming from a GoPro with the process data. And I can take decisions. So here is the real revolution. That I build up a system to take